Dear children, the first concept in the chapter Work, Energy and Power is the work. You know that work is said to be done whenever a force acts on a body and the body moves through some distance in the direction of the force. Here, when a work is done on the body, two conditions must be satisfied. First one is the force acts on the body. Second one, the body must move through some distance and the direction of the force acts in the direction of the displacement or the distance. Okay. And the examples of the work done is work is done when a horse pulls a cart, an engine pulls a train, etc. Here in this chapter, we want to study about what is the work done when a constant force acts on a body, when a variable force acts on a body. Okay. First concept, work done by a constant force. So there, when a force acts along the direction of motion, then what is the work done? So look at this figure. Here we are applying a force in parallel to the surface. Okay. So due to this force, the body moves in the direction of force. That is, the body moves through a displacement d and reaches here. So here the force acts along the direction of motion. Clear? The force acts along the direction of motion, that is along the direction of displacement. Force and displacement is in the same direction, that is in the direction of force. Okay. So we can define the work done as force into the distance moved in the direction of force, that is noted as W equal to F into D. Once again, here the force and the displacement are in the same direction. Force acts along the direction of displacement. So we can write W equal to F into D. But when the force and the displacement are inclined to each other, then what is the work done? This is the main concept we are going to study in the chapter. Work done, what is the work done? When force and displacement are inclined to each other. So here, when we are applying a force inclined to the surface, okay, we are applying the force inclined to the surface with an angle theta. That means we are applying a thread on a box and we are just move like this, isn't it? So what happens here? The force is applied in a direction theta. That means in a angle theta with the surface. So what happens here? This force splits up into two components. One is the horizontal component and another one is the vertical component. So the horizontal component is the F cos theta and the vertical component is the F sin theta. So when the body moves through a displacement d and reaches here, then what happens here? The body moves in the direction of the component of force F cos theta. Okay. When we are applying the force, the body moves in the direction of the component of force F cos theta and moves through a displacement d. Clear? So in this case, what is the work done? Work done is the component of force in the direction of displacement and magnitude of the displacement. So we can write W equal to, in the first case what we written, W equal to F into D. Okay. Similarly, here we can write the component of force into magnitude of the displacement. That is noted as W equal to F cos theta D, that is equal to Fd cos theta. In vector form, we can write F vector dot D vector. Clear? So, work done by the force is defined to be the product of component of the force in the direction of the displacement and the magnitude of this displacement. That is W equal to Ft cos theta equal to F vector dot D vector. Then what is its SI unit? From the formula we can write force Newton and the displacement meter. So, Newton meter, or we can write the unit Joule. Symbol capital letter J. This is named after the British physicist James Prescott Joule. Then what is the dimension? ml square t raised to minus 2, you already studied. Then there are some cases, that means we can say the meaning of the work done in physics is different from its usage in everyday life. So for example, here we can see some cases and examples are there. So the work done is 0. Okay, work done is 0. If there is no displacement, then if there is no force, and the third one, the force and displacement are mutually perpendicular. So we can go through one by one. So first case, the work done is 0 when the displacement is 0. So in the formula, when the displacement d equal to 0, then what is this quantity W? W equal to 0. Okay. So one example here, a weightlifter holding a mass steadily on his shoulder for some seconds, it does not doing any work. He does not doing any work. That means when a weightlifter holding a mass steadily on his shoulder, he is applying force but there is no displacement. So in that case, there is no force. Okay. For example, here I am lifting this pen, isn't it? So what happens here? There is force and the displacement is there. So in this case, we can say that work is there. But when I am holding the pen like this, what happens here? Force is there but the displacement is 0. So there is no work. In physics we can say that there is no work. Okay. So clear? So displacement is 0, then the work is 0. Then the second case, force is 0. So in the formula F equal to 0, then W equal to 0. Example here, a block moving on a smooth horizontal table. Smooth horizontal table means there is no frictional force. We can assume that there is no frictional force. So it is the smooth horizontal table. So when the block moves on a smooth horizontal table, what happens there? There is no force. But what is there? There is large displacement is there. So if there is no force, work is 0. Okay. So this is the second case. Then the third case is the force and displacement are mutually perpendicular. There the angle between the force and displacement is equal to 90 degree. For example, when the block moves on a smooth horizontal table, that is no frictional force is there. Gravitational force mg does not doing any work because it acts at right angles to the displacement. So here when a block is moving on a smooth horizontal table, the frictional force is 0. Okay, there is no frictional force. So what happens here? You will think that there is a gravitational force acting downwards. It is equal to the weight of the body. But here this gravitational force mg is perpendicular to this direction of displacement. Okay, that is the angle between this gravitational force mg and the displacement is 90 degree. So in the formula W equal to F D cos 90. Okay, cos 90 0. So W equal to 0. Okay, so these are the three cases in which we can say that there is no work done. nature of work done in different situations. You know that work done is scalar quantity, but it may be positive, negative or zero. So we can see the positive work, negative work and zero work with some examples. So what do you mean by this positive work? If the component of force acts in the direction of displacement, then the work done by the force is positive. That is, the angle between F vector and the S vector, displacement vector, theta is less than 90 degree in between, that is theta is in between 0 degree and 90 degree, which means that theta is acute, acute angle. This component of force acts in the direction of displacement, then the work done by the force is positive. So we can see some examples. So first example, when a horse pulls a cart, what happens there? The applied force and the displacement of the cart are in the same direction. So the work done by the force is positive. Then second example, when a body falls freely under gravity. So here you look at here, when a body falls freely under gravity, then what happens here? The gravitational force and the displacement of the body are in the same direction. In that case, the angle between the gravitational force and the displacement of the body is 0. So the work done by the gravity is positive. Work done by the gravity is positive. Then second one, negative work. If the component of force act in the opposite direction of displacement, the work done is negative. That is, theta is greater than 90 degree, that is in between 90 degree and 180 degree. So here the component of force act in the opposite direction of the displacement. So F cos theta and displacement S vector is in the opposite direction. So the angle between these two are 180 degree. So in this case the work done is negative, that is theta is obtuse angle. Example, when a body slides against a rough horizontal surface, its displacement is opposite to the force of friction. That is, the body moves in the rough horizontal surface in the forward direction. So the displacement is opposite to the force of friction. So in that case, work done by the force is negative. Then second example, when a body is lifted, when a body is lifted, the work done by the gravitational force is negative. This is because the gravitational force acts vertically downward while the displacement is in the vertically upward direction. So when you are lifting a body like this, the gravitational force is acting vertically downwards and the displacement of the body is in the upward direction. So the component of force and the displacement is opposite to each other. So in that case the work done is negative. Clear? Then next one, zero work. Work done is zero if the body gets displaced along a direction perpendicular to the direction of the applied force. So this case we already studied. Anyway, so the first example, for a body moving in a circular path, the centripetal force and the displacement are perpendicular to each other. So work done by centripetal force is 0. So for example here, when a body is moving in a circular path, then the centripetal force is acting towards the center and the displacement of the body is perpendicular to the centripetal force. So the theta is 90 degree. So work done equal to 0. So in the same way also the moon circulating in the orbits of, that is circulating around the earth. So in that case the centripetal force is acting towards the center and it is perpendicular to the displacement. So the work done by the centripetal force on the moon, that is equal to 0. So in the likewise in every planets the centripetal force is acting towards the center. So work done in that case is 0. Then the second one, when a coolie walks on a horizontal platform with a load on his head, he applies force on it in the upward direction equal to its weight. The displacement of the load is along the horizontal direction. So in that case, theta between force and the displacement, component of force and the displacement is 0. So work done is 0. So here, when a coolie walks on a horizontal platform with a load on his head, so what happens there? He applies force in the upward direction, okay, on the load equal to its weight. But he is moving in the forward direction, so the displacement of the load is along the horizontal direction, that is in the forward direction. So here the displacement and the component of force are perpendicular to each other. So in that case also work done is 0. Work done by the coolie on the load is 0. Okay.